Another way to solve a system of equations is to use what's called the addition method, also known as the elimination method. The substitution method is really useful if one of your equations already has a variable isolated, or if a variable has a coefficient of 1. Okay, if that's not the case, then the substitution method might not be the best method, and the addition method might be a better method. So like the substitution method, this method involves eliminating a variable and ultimately solving an equation containing only one variable. This time we'll eliminate the variable by adding the two equations together rather than doing a substitution. The key to using this method is going to be having one variable in each equation have the same but opposite coefficient, like 2x and negative 2x in the other equation. So our steps to solving using the addition method: first step, if necessary, rewrite both equations in the form ax plus by equals c. So you need your x's and y's on one side and your constant on the other side. Step 2, if necessary, multiply either or both equations so that the sum of either the x coefficients or y coefficients is 0. Step 3, add the equations together, resulting in one equation with one variable. Step 4, solve your new equation. Step 5, back substitute into either of your original equations and solve for the other variable. And then step 6, check the solution in both of the original equations. This step is optional, but a good idea on tests and quizzes. So example number 4, we have the system 3x plus 2y equals 48, and 9x minus 8y equals negative 24. Okay, so first you want to check and see, do either of my variables in both equations have the exact same coefficient and opposite sign? 3 and 9, no. 2 and negative 8, no. Okay, next, if that's a no, you want to see, can I multiply one equation by a constant and have the two variables have the same coefficient? Okay, and yes, I could. If I multiply 3 by 3, I'll get 9. If I multiply 4 by 2, I'll get 8. Okay, so we want them to have the exact same sign and exact same number and opposite sign. So let's work with the first equation, since if I multiply this by 4, I'll get positive 8, and this is already a negative 8. So we want to take our first equation and multiply everything there by 4. So if I multiply 3 times 4, I'll get 12x. 2 times 4, 8y. And then 48 times 4, 192. Our second equation stays the same. And then what we'll do in step 2 is to add, or step 3, sorry, add these equations together to result in one equation with one variable. So if I add these straight down, positive 12x and positive 9x. So 12x plus 9x is 21x. Positive 8y and minus 8y, so that's 8y minus 8y is 0. That was the point. And then equals, on the other side, 192 minus 24 is 168. Last thing to solve for x, divide by 21. And then we'll get a solution of 8. So we have half of our solution, x equals 8. Okay. Step number 5, we want to back substitute x equals 8 into either one of our original two equations. It's up to you which one you use. General strategy is just use whichever one looks like it has smaller values. So maybe we would choose to use the first one since it has a 3 and a 2 rather than a 9 and an 8. So let's use our first equation. 3 in place of x, we use 8 plus 2y equals 48. So we want to solve this equation for y. We'll have 24 plus 2y equals 48. Subtract 24. 2y equals 48 minus 24 is 24. And then our last step, divide by 2. So y equals 24 divided by 2 is 12. So our solution, x equals 8 and y equals 12. As an ordered pair, 8, 12. Example 5, we have the system 4x plus 6y equals 10, and 6x plus 9y equals 12. So starting point again is to see, do either of your variables have the exact same number and opposite sign? And no on this one. Second thing is, can I take and multiply one equation by a value and get the other variable to match? Well, if I multiply 4 by 2, I get 8, which is already bigger than 6. So without using a fraction, I can't multiply 4 to get 6. Okay, if I look at 6, if I multiply 6 by 2, I get 12, which is bigger than 9. So without a fraction, I can't multiply and turn 6 into a 9. So in this case, what we want to do is multiply both equations by something to make either x or y match up. And it doesn't matter which you pick. You can either make the x's match or the y's match. Let's say we want to make the x's match. So x, we have a 4 and a 6. So we want to think of what's the smallest number that 4 and 6 divide into. And that would be 12. So if I multiply my first equation by 3, I will get 4x times 3 is 12x plus 6y times 3 is 18y equals 3 times 10 is 30. My second equation, if I multiply 6x by 2, I'll get 12x. And since I want them to have opposite signs, let's multiply this equation by a negative 2. So negative 2 times 6x is negative 12x. Negative 2 times 9y is minus 18y. And negative 2 times 12 is negative 24. So now when I add these equations together, 12x minus 12x is 0. That was the point. On this particular problem, though, when I go to the y's, 18y minus 18y is also 0. So in this problem, my variables completely cancel away, leaving me 0 on the left. And on the right, 30 minus 24 is 6. So like other problems, if your variable completely cancels away, look at what you have left, see if it's true or false. 0 equals 6 is false. And if you have a false statement, that means no matter what you pick, you will not have a solution. So no solution. And sometimes, of course, we would represent that with the empty set symbol.